Cosine rule. Again, for non-right angle triangles, okay, again, you need three pieces of, remember, you can only work in a triangle if you have three pieces of information. So if you have three pieces of information on your triangle, you can find out anything you want to know, right? Okay, so the cosine rule, and I'll tell you, I'll get to when you would use which one, when you would use the sine rule and when you would use the cosine rule. Okay, so remember, when you have a non-right angle triangle, you call the angles the capital letters capital A, capital B, capital C, then opposite small a, small b, small c. Is that alright? Okay, the cosine rule, again, it's written in one form in the log tables. So it's a squared equals b squared plus c squared minus 2bc cos a. Right? So a squared is the length of the line A, b squared is the length of the line B, c is the length of the line C, and then capital A is the cos of this angle. Okay, so the cosine rule. That's the way it's written. You can rearrange it to have the letters in different positions if you want. Okay, so if I had, so it's A equals BC, BC, and look, A and A correspond. Okay, so if I had B squared, what would it be? B squared is equal to what? It's the other two, A squared plus C squared minus 2AC cos B. Okay, so that's the same rule, just written with B squared, right? C squared, what would C squared be equal to? A squared plus B squared minus 2AB cos of capital C. Is that okay? So this one is in the log tables, okay, but you can rearrange it. So you can so this one is in the tables, but you can rearrange it, etc. Or you could change your labels on your triangle to work out that you're missing A. Okay? Now, the cosine rule is, as you can see by looking at it, it's harder than the sine rule, isn't it? Remember, don't write this down. Remember, the sine rule was A over sine A equals B over sine B. Don't write this down, leave this, because I'm not doing this, I'm just reminding you. It's been a few weeks. Equals C over sine C. Agreed? Right, that was the sine rule. Okay, so that's easier to use, right? But there's two instances, girls, where you have to use the cosine rule. I brought everything home because I thought we wouldn't be here, but here we are. So the duster is in the bag, I think, I hope. Okay. Right, so when do you have to use the cosine rule, okay? When do you use cosine rule to... Right, there's two instances, right, where you've no choice, but you have to use the cosine rule, right? Okay, so you're given the length of the three sides, So you're given the length of the three sides and asked to find an angle. Remember, this is for non-right angle triangles. Asked to find an angle. Right, so that's one time you would use the cosine rule. So you're given A, B, C, small a, small b, small c, and you're asked to find one of the angles, right? And the second occasion when you would need to use the cosine rule, girls, would be if you're given two sides and the included angle. And you can be asked anything there, asked to find something else. Another side or an angle. Right, okay, so for example, I'm just going to draw out these triangles. So if they told me 5, this was 5, this was 6, this was 7, and they said find angle A, you'd have to use the cosine rule in that instance. You haven't enough information for the sine rule, right? Okay, and the second instance where you would be asked, you'd have to use the cosine rule is if you were told this was 5, this was 7, and this was 40 degrees. So you're given two sides and the included angle. Do you know what I mean by the included angle? The included angle is the angle that the two sides that you're given make. So the 5 and the 7 make the 40 degrees angle. It's called the included angle. Is that okay? So if you're given the 5 and the 7 and the 40, right, and you're asked to find the other side, right, okay, you'd have to use the cosine rule. You don't have enough information for the sine rule, right? Okay, so they're the only instances you would use the sine rule. Every other instance, right, you would, or the only instance you would use the cosine rule. Every other time you'd use the sine rule because the sine rule is easier. Okay?
What's on the opposite side to 5?
Here?
Yeah.
It's just a question mark, sorry. I can't do question mark, I've forgotten. Yeah, as in you're asked to find that side. Is that okay? Right, okay, example. Example 1. And I'll just go with, this is 48, this is 6, this is 8, and this is x, right? So the question is find x. So that's a 6, that's an 8, 48 is the angle, right? Okay. Magnify it a small bit. Okay. So label first, right? So I'm going to call the angle I know capital A. So that means x is small a, right? I'll call this capital B, so 8 is small b, and I'll call this capital C, and I'll call this small c. Is that okay? And then a squared is the cosine rule equals b squared plus c squared minus 2bc cos a. So you fill in what you can. So x squared is what I'm looking for, right? B squared would be 8 to be squared, plus c is 6 to be squared. Now these are all multiplied. See this 2bc cos a, they're all multiplied. So it's minus 2 multiplied by b, which is 8, multiplied by c, which is 6, multiplied by the cos of angle A, which is cos of 48. Okay, into the calculator with that and write it exactly as you see it, right? And press equals, okay? And when you do that, you will get 35.77 dot dot dot, as in there's a big long decimal there, okay? But I want x on its own, I don't want x squared, so how will I get what x is? Get the square root of it. So the square root of 35.77, and that would be x is equal to 5.98, and they told me in the sum rounded up to the nearest whole number, so that means x is equal to 6. Is that right? Are we good with that? And again, they didn't give me any units, but if they give me units, I have to give them units back. So if they gave me centimetres, I'd have to give them centimetres back. Is that right? Okay, right, and now I'll do an example. So that's an example where I've given two sides and the included angle. So two sides and the angle between them. Okay, you haven't enough information there to use the sine rule. If you try to use the sine rule, you have to have an angle, a complete set to use the sine rule, as in you have to have an angle and know the length of the side opposite it. So the angle, I don't know the length of the side and I don't know the other angle, so you can't use the sine rule in that case. Right, example 2, I'm going to give you the length of, can I go? Right, example 2 is the second time where you have to use the cosine rule, where you're given the length of the three sides and you're asked to find an angle. Right, okay, so here's my triangle. So this is 4, this is 5, this is 8, and I'm asked to find angle A. So find A, what side the angle is, right? Okay, is that alright? So in this case, we can't use the sine rule because you need a complete set to use the sine rule. You need all the A's or all the B's or whatever, but you don't have it. So I'll call this capital B, so I'll call this small b, and I'll call this capital C, and this is small c. Is that right? So then cosine rule, a squared equals b squared plus c squared minus 2bc cos A. And as I say, that's in the log tables. So that's a squared is 5 squared, b squared is 4 squared, c squared is 8 squared, minus 2 multiplied by 4 multiplied by 8, and I'm missing the angle, so cos of A. Is that right? I'm missing the angle there, so I can't fill in here, right? I can multiply out what you can. So this is 5 squared is 25. 4 squared is 16. 8 squared is 64. Now here, you can multiply what you know. So 2 by 4 is 8. 8 by 8 is 64. So that's minus 64 cos A. Okay, so just multiply what you know. Are we good? Right. So then what I'm going to do is, I'm missing angle A, so I'm going to bring this term over to the left and everything else to the right. So minus 64 cos A comes over the wall and becomes plus 64 cos A. Over this side, I'm leaving the 16, I'm leaving the 64, and I'm bringing over the 25. So it's just algebra and just moving stuff around. Is that okay? So that would be 64 cos A is equal to, that's 80 minus 65, which is 55. Okay. There's a 64 stuck to the cos A, so I'm going to divide each side by 64. So the 64 is cancelled here. I get cos A is equal to 55 over 64. How will I find out what angle A is? I know what the cos of it is. Sorry, I need to move this up, don't I? Move this down. So I know what the cos of the angle is. How do I find out what the actual angle is? When you're missing the angle, what you always press? Shift, yeah. So you go shift cos 55 over 64 and then equals on your calculator, and that will tell you that angle A is measured 56 degrees when you round it up to the nearest whole number. 55.77, but when you round it up it's 56, sorry. Am I okay to move up like that? Are we good? So I'm going to give you a few of these to try, right? Okay. One is
This one, I thought calculator to do 13.7.
when you do the inverse cos, is, you know, the little writing on your calculator, does it say D? It does say D?
Yeah.
Wait now till I see. Yeah, because I have it. Yeah, I probably wrote it down wrong or something, did I? Yeah, I wrote it down wrong. So, yeah, so I took the answer from the book, but I have it written down differently. So what answer did you get? Sorry.
30.7535.
Yeah, so that's 31 degrees. Can you change that, girls? Because I wrote it down wrong. I copied the example out of the book, but I wrote it down wrong. But it's okay, it's just different figures, same method. Okay, 31 degrees. Okay, so page 546, girls, to 547. Right, we're going to do all of question 1, which is the exact same as example 1. Right? Okay, and then we're going to do all of question 3, which is the exact same as example 2. Okay, so there's 3 parts in question 1, they're all the exact same as example 1. There's 3 parts in example or question 3, they're all the exact same as example 2. So off you go with them, see how far you get, right? Okay, and we'll iron out any problems there. Okay.
Do you put up a picture of the...
I will.